All right, let's start practicing together. So there are 4 types of nucleophilic acyl substitution. Okay. Again, do not memorize any of those. All you have to do, just look at case by case. Like as you draw the mechanism, let's see, look at the product, look at the reactant, and see what you have to do. All right, let's say this one we have acid chloride. That's your nucleophile, and as ammonia, that's the nucleophile. No, acid chloride is an electrophile. Ammonia is the nucleophile. So nucleophilic attack. So we will break the double bond, get an alkoxide like that, tetrahedral intermediate, and then expel the leaving group. Yeah, leaving group comes out, and an acid-base reaction. Yep, deprotonation. Here we go. That's it. All right. So you should realize that once you get to this intermediate, this compound is charged. So you have to get rid of the charge by doing either protonation or deprotonation. In this case, it's an acid, so you do deprotonation. Okay, so do not memorize what's going on here. You just look at case by case. All right. This one, so we have less reactive reactant. I mean, starting material, and your reactant is reactive. Okay. All right. So reactive reactant attack right away. Nucleophilic attack. So from double bond, break it, you get a single bond. sp2 carbon become an sp3 carbon. Okay, that's a tetrahedral intermediate. And then remove the leaving group. So you got 2 options: either remove a hydroxide as a leaving group. If you do that, you go backward and doesn't go anywhere. All right. To go forward, we're going to remove the ethoxide. Here we go. All right. One thing you should realize that this is a basic condition. Do not make a strong acid. No hydronium ion in here. All right. And we're not done yet. So look at the product though. All the product you have a carboxylate, and this is you got an alcohol. So that's the base. This proton here is acidic proton. So deprotonation. Here we go. That's the product, and ethanol as well. Okay. All right. One more. So this is going to be long because we have a less reactive starting material, so you probably have to activate it first before it can do a reaction, and that's the reason why we add the catalyst and acid. Okay, ethanol is used as a solvent. All right, so ethanol will attack on the carbon. You get an ethyl group right there, ethoxy group. I mean, all right, first step. So add an acid. The first step always deprotonation. So there are 2 possible nucleophile, 2 possible bases. All right, so we get the sp2 oxygen and then sp3 oxygen, and of course sp2 oxygen bear localized electrons, so that's more higher electron density. So the reaction happened there. So all right, protonation. So you get this compound. So we activate it. At this step. Next step is ethanol coming and attack. All right, so remove from break double bond. And next one, deprotonation. Here we go. All right, we get a tetrahedral intermediate. Okay. Now take a peek at the product. So the product does not have an ethoxy group. All right. So we have an ethoxy group. So we have to get rid of something that's not ethoxy group. So water right here. So an OH will have to come out as water. So protonate it. Whatever you want to get rid of. So we protonate or activate it. And then I'm going to need to put a double bond right here. So use double bond and expel the leaving group, the water. All right. All right. Get to this point. So your this compound here is a positively charged, right, compound. So what do we have to do? Well, we have to make it neutral, get rid of the charge by either protonation or deprotonation. Well, this guy's an acid, so you have to do deprotonation, right? And here we go. That's your product. So ethyl benzoate. Okay. All right. Hope this helped. Let's go to the next video. We'll learn I'm gonna link it to biochem. Okay.